Following video is part of my practical TypeScript course. And if you wish to enroll in the full course, please navigate to codingaddict.io. Again, the URL is codingaddict.io, or you can utilize the link provided in description. Okay, and we have successfully arrived at the most complex and confusing topic in TypeScript, which is none other than the generics. In short, generics allow us to write, for example, functions with any data type. And you can think of generics as a variable for types. Now, I'm not going to sugarcoat it. It's not an easy topic. The good news is, though, that most likely in the beginning, at least based on my experience, you'll primarily use generic functions or interfaces created by somebody else, whether it be the creators of TypeScript or developers of some third-party library. And in that case, you'll only need to remember one concept. Every time you see those funny-looking angle brackets, think generics. And let's begin by taking a closer look at the arrays in TypeScript. So at this point in tutorial, we should be already familiar with the syntax. So we have three variables. The values are arrays, and here we just say, well, what is the type for the array? And as we're looking at this code, and we're just focusing on TypeScript, so please don't tell me that the answer here is the keyword let. As you're looking at this code, what is the one thing that doesn't change? So what is the one thing that stays the same? And it's kind of pretty obvious, but I do want to start from this point. And the answer is following. Notice how the type is changing here all the time. But we're always getting this array. Now, of course, we can make this complex. We can provide our own type. We can provide the union type, whatever. That doesn't change the main idea. We're always getting back this array. And not only that, we can pretty much pass here whatever we want as far as the type, correct? So it still needs to make sense as far as type. And we'll always get back the array. So it's not like I need to go somewhere and look for string array. No, I don't have such type. I literally just have this one universal one that I can use. Because if you think about it, how difficult it would be that not only we need to remember, but also to construct such types. Let's say we'll need to have one numbers array type, then one Boolean one. And I can go on and on and on and on. And actually, we can examine what type are we getting back over here. So let me remove this silly text. And now let me right click. Then we want to go to type definitions. And yes, I know we haven't covered the declarations yet. Don't worry, all of that is coming up. And you know what? I'll actually pick the third one because it's going to be easier for me to show you. So let's go here to type definition. And then we're looking for this declaration one. So we're looking for lib es5d_ds. Again, we haven't covered them, how we have access to them and all that. All of that is coming up. For now, let's just focus on this code. So notice we have this interface. Again, something we should be already familiar with. Remember, we use it to provide shape of an object. The name here is an array. And check it out. We have the funny looking angle brackets. And inside of it, we have this T. Now, right away, I want to mention T is convention. You can call this shake and bake. You'll see that in a second once we set up our own generic interface or function or whatever. Basically, this represents the notion that this type can be anything. So I can pass here the string, number, Boolean, my own type, you name it. And every time, not only I'm going to get back the array with that specific type, I'll also get all of the properties and methods that we know already exist on array. So what am I talking about? Well, we know that length is part of the array, correct? We can just call our array.length and we're good to go. So notice we have over here this method. So we can definitely use it. And then let's keep on moving. And we'll see again all of the functions we're already familiar with. But here's the kicker. For example, pop. Now, if you're not familiar, this essentially is a function which removes the last element from the array and returns it. But now notice, what is the return here specified for the pop? It's not string, number, or boolean, or your own type. No, it's basically this t. It's basically this generic. So whatever I pass in, whatever array I construct, well, I want to remove that last type, correct? I'm not saying, hey, this is the array of strings, and now I need to call specific method to remove the string. No. Basically, whatever type we use to set up that array, well, that's the same type we remove. And notice how essentially we're saving a bunch of the code, because imagine if you would have to set up such interface pretty much for any type that we can pass in the array. I mean, you'd go most likely insane. So that's why we use this variable where we say, okay, you can pass in any type and it's going to get treated the same way. We'll create the array the same way. We can call the methods the same way. So none of that changes. So whatever type we pass in, well, that's the type we're going to use to operate. So hopefully, again, this is clear that it definitely makes sense in a lot of instances to set up the generic one, because you don't want to set up essentially the interface for every possible type that you can pass into array. And now knowing this, we can actually take a look at the second approach we have to construct the arrays. Now, I can tell you right away that just because we know the generics, you won't have to use the syntax. So you can still use this, I would say, more user-friendly syntax, but I do want to showcase that since this interface is an array, we also have this option. So now let me comment, I guess, these ones out. You know what? Let me start everything from scratch. So I want to go here with let, and again, I'm going to call this array1. And then as far as the type, sorry, I'm not going to go with string. I will go with array, and then let's pass in the string. And now, as far as the result, well, that one is actually exactly the same. So I'm just saying, yeah, it's going to be an array of strings. And again, this doesn't change. The only thing that's going to change, the type that we're passing in. So if we pass in the string, and of course, we'll get back array of strings, as well as all the methods that we can call. So if I call the pop on this one, on array1, guess what? It's going to remove the last item, and the type is going to be string. And of course, we can repeat the same for number and boolean. And with this in place, now we can move on to the next topic. All right, and once we're familiar with the main concepts, let's construct our own. Let's start easy. Let's just go with the function as well as the interface. So here's the goal. We want to create a function which is going to take any type and return the same type. So one approach could be following. We can go with function, then let me go with create string. As far as the argument, I'm going to call this string. Basically, I'll give it a type string. It returns a string. And then from the function, we return the argument. Now, everything is awesome, but we pretty much need to return the same function for any type. So we need to create one for the number, for boolean, and rest of them. Now, I'm not going to create function for all of the types, but you know what? Let me just showcase with the number. So let's say if from this function we want to return a number, this is what we'll need to do. And as you can see, this gets annoying pretty fast, correct? And we only have two types. So this is what I was mentioning in the previous video. Imagine that array interface, if it's not a generic, but pretty much you'll need to copy and paste. And everywhere where you have a string, you'll have to change it to number and boolean, and then rest of the types. So what's the solution? Well, this is where we use the generic. I will leave this one for your reference. Or you know what? Actually, you have it in a README. My bad. Let's start from the scratch. I think it's going to be better. We're going to go with function. then let's call this something generic. And I think generic function is good enough. And we will set up the parameter. We will set up the logic. Now I want to set up the variable for my type. So instead of hard coding, instead of number and string, I'll say it can be any type, and both my argument as well as what I'm returning are going to be that type. So we go here with this angle bracket. Like I said, you can call this shake and bake. Just make sure you use the same name. And again, the convention is just to go with T, which stands for type. So we go here with T. Then we say that, yeah, argument is actually going to be this type. So I'm not going to say that it's a string, number, or whatever. No, whatever type we have over here. And as far as the return, we'll also go with the T. This is what I'm returning from this function. And now we just need to set up the logic where we return the argument. So now we can go here and set up some string value, set it equal to generic function. Then, since I'm creating a string value, this is the type I want to pass in. And then I just want to provide a string. Let's save this. And now I can do the same thing for the number. So instead of string, we're going to go with number. And instead of type string, we'll set up the number. Now, it does need to make sense as far as the argument. So it's not like I'll randomly pass in the string. As you can see, Typescript is complaining. And we set up over here the number. So now we can use this function with any type, even the ones that we set up ourselves. So this is not limited anymore to one specific type. This right now is generic function where we can pass in any type and we'll get back the same type. And while we're on topic, let's also take a look at the interface. So I'm going to go with interface, and let me right away call this generic interface. Same deal. If we want to set up a generic one, we already know that we need to go with angle brackets. Let me stick with convention with the T. And then there's going to be a value property. The type will be whatever we're setting up over here as T. That's why they need to match. And let's also set up the get value function, which is not going to take any parameters, but it will return the same type. And now let's create a new instance. I'm going to call this generic string, which is somewhat funny, but let's just stick with that one since I have that in a README. So we're going to go with generic string. We go here with generic interface. We say that, yep, as far as the type, it's actually going to be a string. And now inside of our instance, of course, we need to follow the same rules. So the value I'm going to be setting up has to be a string. So we'll go here with hello world. And then as far as get value one, well, let's just return this dot value. Return this dot value. Let's save it. And once I save, I have right now the string instance from my generic interface. So this is how we can construct our own generic functions as well as generic interfaces. All right, and before we start working on the more complex examples, I do want to showcase something. Most likely, as you're looking at these first few examples, you're like, I mean, this is ridiculous. What is the actual need for such functions? I mean, I do understand, yeah, there's angle brackets. Yeah, I can use this T and it's going to work with any type. But in reality, this is just silly. Okay, hold that thought. And let's just set up a async function. And remember, in JavaScript, what do async functions return? They return a promise. So let's go here with async. Let's call this function. I'm going to go with some func. For now, let's not worry about the return. Or you know what? No, let's set it equal to a string. I do definitely want to showcase something. So we right away have the error. This is something we're going to deal with. For now, let's just return and hello world. So technically, it's kind of correct. We're returning a string. So what is TypeScript complaining? Well, again, Async functions return what? They return a promise. So now let's do the same thing like we did with the arrays. Let's look at the type that we're getting back. And hopefully in the process, you'll see that even though this might look somewhat silly, essentially this is the foundation that you'll see over and over and over in documentation. So if I'm going to go here with the result and some func, and we'll take a look at the result. I mean, it says that it's a string, but we clearly have this issue over here. And notice now we have this, the return type of a sync function or method must be the global promise. Again, funny looking angle brackets type. Did you mean to write promise? And interesting. We actually have the generic again. So you know what? Let me remove the return type for now. I'll rely on Typescript to infer the type. And now let's click on the result and type definition. And same deal. Notice we have over here this interface. The name is promise. And again, it's a generic. And yes, it has a little bit more code. But notice the general idea. Effectively, we just get back this promise. And in there we have the type. So the point is that every time we have this async function, we do need to set up promise as a return type. And we just need to remember that it's a generic. So instead of typing string like I was doing before, we just go with, okay, we're returning a promise, but since it's a generic, we need to specify the type in the angle brackets. So again, the main point is that, yes, I know that this might look silly, but keep in mind that this is going to be the foundation that you see in documentation. As silly as it looks, it actually handles all of the cases that we're interested, because in here, I can return whichever type I need in that particular instance. And I simply just need to provide the value over here in the angle bracket. So let's say if I'm going to go with 234 or whatever number, then it's going to complain. So now I just need to go over here and say, yeah, I will return a promise because it's a sync function, but the type in this case is going to be a number. So yes, even though our first two examples might look super silly, they use the same concepts that you're going to see later in declaration files. And with this in place, now we can move on to the next topic. All right. And once we're familiar with the fundamentals of generics, let's work on a tiny challenge where we want to set up a function. In my case, I'm going to call this create array, which takes in two things. It takes the number length. So that just controls the length of the array. So if I pass here 3, then I'm going to have 3 items. If I have pass here 15, then obviously it's going to be 15. And then the second thing is going to be the actual value. So if I pass in the string, then I should be getting back the array of strings. If it's going to be number, then it's going to be an array of numbers. And hopefully you see where I'm going with this. And I guess let's start again by hard coding. Hopefully in the process, we'll see why we want to use generics. So first, let's create a function. I'm going to go with generate string array. Like I said, we're looking for two things. Length, which is going to be the length of an array. And also, well, what is the actual value? And as far as the type, I'm going to go with string. Now, from this function, since I'm taking in the string type, I want to return a string and array. Now, when it comes to logic, I want to create the result variable. This will actually be string and array. And for now, it's just going to be empty array. But yes, we're going to store over here the strings. Okay, good. Then let's assign result to array. So again, we can use our object. In there, first we want to pass in the length. So how long is going to be the array, how many items we're going to have over there. And then let's just call the fill method. So pretty straightforward. Whatever value we pass over here, we'll add to our result. So we'll call fill and we'll pass in the value. And then from this function, since I want to get the array of strings, let's just go to return and a result. Let's save it. And again, everything is awesome, but I need also the same array for numbers, booleans, or any other type. So now we just need to make this function generic. Or you know what? Let me just quickly showcase that the code actually works. So generate string array. How many items? I don't know. Let's go with 6 because I have the example of 3. So you probably don't believe me. Let me go over here and notice everything works. So I get back my array. It's type string and I have 6 items. Okay, beautiful. So now how I can make this function generic. And again, most of the logic is actually going to be the same. The only difference everywhere where we have the string, we just want to convert it to a generic. We want to convert it to that variable. And as a result, we'll be able to pass pretty much any type. So let me copy and paste. Instead of generate string array, we'll just call this create array. Create array. Length stays the same, but this one actually is going to be equal to a t. And now we want to set up that angle bracket. So again, we set up this variable for the type and we pass here dt. So now everywhere where we want to reference the type, we'll use the t instead. So in here, instead of string, instead of hard coding that, we'll go with array and pass in the t. Then instead of strings, we're going to say that, yeah, the result is going to be just an empty array of this specific type. This doesn't change. This doesn't change. Now we just want to invoke it and we'll do the same thing. Like in the README, we're going to go with strings, then create array. We want to provide a string over here. And as far as the value, let's go with 10. The more, the better, I guess. Let's copy and paste and let's call this numbers. So numbers, this will be a number. Let's go with 15. And as far as the value, I'm going to go with 100. So now we just want to log both of these values. Array of numbers and strings. Strings, let me move this one up. Just because, don't ask me why. And if everything is correct, this is the result we should see in the console. So this is how we can create a function which takes any type and returns an array with specific length of that particular type. All right, and up next, let's see how we can set up multiple variable types. And in my case, I'm going to use the function example. So we want to set up a function called pair, which takes in 2 parameters. However, the type is not going to be the same. And then from the function, we just return both of those parameters. But again, we need to return the same types. So let's go here with function. Again, the name will be pair. We start with our good old t. So we already know that one. But if we have multiple variables like this, we just add a comma and then provide the value. Again, it's a convention to go with tu, and then if you have more parameters, just follow the logic over here. But you can name them, of course, differently as well. Then we're gonna set up our param, I guess, 1. So this one will be equal to t, and then param 2 is going to be equal to u. Like I said, from this function, I want to return an array, and I want to keep the same types. So this will be equal to t and u. And let's just set up the logic where we have param1, comma, and then param2. So now let's invoke it, and if everything is correct, we should get the correct result. So we're going to go with the result. That one is equal to pair. And then I'm going to go with number and a string. Let's go with 1, 2, 3 and hello. And check it out. TypeScript is not complaining. So if you have more variable types, add a comma. And then the common approach is to go with you and then rest of the letters that follow you if you have more parameters. Or you can come up with your own names. Just make sure you use the same name in the parameters as well as the function logic. And up next, let me quickly show you that TypeScript can still infer the type even if we don't provide the types here in the angle brackets. But just like before, we need to be careful. Yes, if you are expecting to get back the number in a string, everything is awesome. But if by mistake you pass in some other type, it's not like TypeScript can magically figure this out. So therefore, if you don't pass in the types you're expecting, just make sure that you pass in the correct values. Hopefully that is clear. And as a side note, this is something that we're going to see later when we start working with React, where use state hook actually is a generic, which again, if we think about it, kind of makes sense, right? I mean, we can pass in string into use state, same how we can pass in the array. So this use state hook needs to accept whatever value we pass in, whether that is a string, number, all the way to array of objects. And essentially, since it's a generic, we can technically bypass the angle brackets. So let's say if it's a string, I just let TypeScript to infer that yes, for sure, it's going to be a string since I'm passing in the empty string. But for example, when we're going to be setting up the arrays, TypeScript is going to complain. And at that point, we'll need to specifically let TypeScript know, hey, is it going to be an array of strings, numbers? And in this case, I'm just coming up with some fake product type. So hopefully that is clear. Yes, TypeScript can still infer the type. Just be mindful when you use such approach. And also, I want to show you how we can set up the constraint on a type. Essentially, I can limit the type options I can pass in. So let's imagine this. I have a function of process value. Function process value. And in here, I have my generic T. But I only want to limit this to a string. So the keyword we're looking for is extends. And then in here, we pass in the specific type. Now, in the following video, I'll show you a different example. So don't think we can only use it here with primitive types. But let's just start nice and easy. So we're going to go over here with the string. Then we want to set up a parameter. Again, I'm going to say that it's equal to a T. And you know what? Let's say that we're also going to return it. So in here, let's log it. Let's say value. And let's also return the value. Let me save it. Let me call process value. Now, in this case, I'm just going to infer the type and I'm going to say hello. And as you're looking at it, you're like, well, I mean, at this point, we can simply set up a function without the generic, correct? So I can simply say that, yeah, I'm going to be passing in a string and I'm expecting a string back. And you're 100% correct. So with this particular example, I mean, there's no real benefit of setting up the type and then extending it only down to a string. But again, it is an option, and in the following video, you'll see a more complex example where actually it definitely makes sense. Now we can also use the union type. So effectively, I can go with the string or number. And at this point, if I call in process value, I'm able to pass in the number as well. So for example, I can go with 12. Now, if I'm going to go with process value and then pass in, I don't know, true, then of course TypeScript is going to complain because we can only pass in a string or a number in this generic function. And once we're familiar with the extends keyword, now let's see a more complex example where we have our own types. So let's imagine the scenario where I have type car, two properties, branded model, both of them strings. Then I create the instance. Same with product, only in this case, the properties are name and price, and I have a string and number. Again, I create the instance, and the same with student. So the property is the same. The first one, name, it's a string, but then the second one is age. And in here, I want to come up with a function. I guess I'm going to go with print name, because why not? Where I just want to access the name property. So let's go with our function, print name. Then let's provide the type. The generic in this case, we're going to say that input is also going to be t, and we're not going to return it, so I'm going to go with void. Now, even if we just try to console log input.name, Typescript is going to complain. Why? Because it has no guarantee that there will be that name property. So in this scenario, we're not going to extend to a string. We actually need to look for the types which have that name property, correct? And in our case, we can either go with the student or with the product. We just set up over here extends, and we go with student. So just like before with string number, boolean, or whatever, we can use our own types as well. So now if I go and invoke the print name in here, and if I'm going to pass in the student, everything's going to work. Now it's going to fail if I pass in the product, even though it has the name, correct? Let's try it out. So I'm going to copy and paste. And once we invoke the, not print name, sorry, we're looking for product. Of course, Typescript is going to complain because the type is product in this case. So yes, we can still use over here the union type and pass in the product, but there's actually a better way, because if we think about it, what are we going to do now? We'll look for all of the types where we have the name, and then essentially just use the union type and add it to extends. I mean, technically it's an option, but like I mentioned, there's actually a better way. And that better way is that we can set up an object. We can set which property we're looking for, and then we can pass here in the extends. Now we can set it up as a separate variable, or we can pass here directly. So instead of passing in my student or product types, I can simply set up an object, and I can say, hey, listen, I'm looking for name property, and it has to be a string. So now Typescript is smart, where it says, okay, so student, yeah, it does have a name, so everything is going to be fine. Same with the product, but if I'm going to try to call it with a car, it's not going to work because there is no such property. So if I pass in this instance, notice essentially it complains that the name property is missing in the car. So this is an interesting way how we can use extends, not only with the primitive type or our own custom type, but also we can simply narrow it down to the shape that we are expecting. Okay, and at the very end of generics, let me show you how to set up default type. Just please keep in mind that it's not going to be super useful in our examples, since we're hard coding all of our data anyway. Basically, they're going to be far more useful when we don't know what is going to be the shape of our data. So let's imagine we have interface. It's going to be a generic, and I'm going to call this store data. I'm going to say that I'm expecting t, and then inside of it, there's going to be a data, and it's going to be equal to an array of types. So whatever we pass over here. Then let's set up store numbers. So store numbers, and first let's set up the type. So we go with store data, then number, and then we set it equal to data. And in here, since I want to store the numbers, I'm just going to go with 1, 2, 3, and 4. Okay, so this works. But what if, let's say, I have some random stuff? What if I don't know what I'm going to have in the array? Well, let's try it out. So we're going to go with random stuff, set it equal to store data. For now, we're not going to pass anything in. We're going to go with data, and then we'll set up some random stuff. So I'm going to go with my string over here as well as the number. Now, store data is expecting the type. So at the moment, essentially, we have two options. Either we set up over here the default one, then we won't get the error over here. Or since let's say I'm not sure what data I'm expecting back, technically I can hard code here any. I can say, yeah, I'm not sure what values I'm going to have in this array. So I'm just going to go with type any. Now, if we want to bypass this, essentially passing in any if we don't know what data we're expecting, we can simply set t equal to any or any other default type. As a side note, you can go here, for example, with string or whatever. It's just somewhat common to see any as default type. And in that case, we don't need to even provide it. So if I don't provide the type, then right away, Typescript is going to use any as my default one. Again, kind of hard to see over here because we can clearly see basically what we have in the array. But just to showcase that I'm not making this up, let me grab the example from the README. So if you're interested, you can also copy and paste. Now, there might be some errors since I don't have those values over here. Don't worry about it too much. I just mainly want to showcase some stuff. Most likely you're familiar with the library called Axios, which is super popular to make HTTP requests. And normally the syntax is following where we go with Axios, then the method. Now by default it's get, but in here I hard coded get as well. And we pass in the URL and the data is located in the object in the data property. Now, if we take a look at their documentation, we can actually see that get is a generic. What does that mean? Well, it's looking for the type, but if it's not passed in over here, it uses any. So if let's say you just called axios.get, it's going to set data as any. So whatever we're getting back. And we can actually see that if we continue inspecting the documentation. Notice there's also a second one, which is R, and that one by default is equal to Axios response, and it uses the type we pass in. So essentially, this is another generic interface, which is used as a second type over here. And essentially, it uses the T that we pass in. Now, if we take a look at the Axios response in our generic one, we can see that we're getting back this data, and this is set equal to T. But again, the default value is any. So for example, if we don't provide any info on a type, it's going to be equal to any, because that's the default, as we can see. It's used over here, it's passed down to Axios response, and the same deal in the interface. Now, if we set up the angle brackets and specifically say that, hey, listen, I'm fetching this data, but I know that the structure is going to be following. I'm going to get back the array of objects, and in there, I'm going to have name, which is going to be a string. In that case, this data will have this shape. So if we provide essentially a shape that we're expecting, then this T becomes that shape and goes all the way down to data. Now, if not, then they use the default parameter and essentially it's set equal to any. Now, I know it's a lot of code in here, a lot of angle brackets and that, but hopefully it's clear how we can nicely use type any if we don't know what shape we're getting back. Because again, think about it. This is an HTTP request. So the shape can literally be anything. And therefore the default one is any. And then if we provide specific shape, well, that's the shape we're going to have here in this data property.